So in this video we are going to look at solving a system of linear equations by graphing. So before we ever start actually working some problems, I wanted to talk to you about, first of all, what is a system of linear equations, and then also what are some possible answers that we're going to have as we solve these problems. So first off, a system of linear equations is just a set of equations, or more specifically, we're really looking at lines for us, just like we were looking in our previous chapter when we were graphing lines, where we graph both lines and determine how the lines interact. And what we're really looking for when we're looking at solving a linear equations is we're actually looking at where the two lines meet, if they do indeed meet. So that single point, so our answer for the most part, but not every time, will be the point where the lines cross. Now notice I said almost every time. Not every time is that going to be our option. So what I wanted to do next is just talk to you a little bit about what possible answers, and we actually have 3 possible answers that we can use for solving system of linear equations. The first option is the two lines cross each other. So on a graph, what that would look like, and I'm just doing a really rough graph here, it's not anything fancy, I just want you to see exactly what we're talking about. So on a graph, that would look like if I had 2 lines graphed, and again, I'm just randomly graphing 2 lines here. This point right here, where those 2 lines cross, that is your answer. And your answer is going to be in the form of a point x comma y. Remember, it's just like a point when we were graphing points in our previous chapter. We want to put the x first and then the y, and we're looking at where those 2 lines cross. But you might think, well, that's not, does that happen every time? No, actually, it doesn't happen every time. That's why we have 3 different options. Our second option is when the lines are parallel. Okay, if you'll remember, parallel means that the lines never cross each other. So that would look like, again, if I'm just doing a really rough graph here, and I would have 2 lines going in the same direction and never crossing each other. Those lines are parallel. And for this guy, we actually say there's no solution, because we're asking ourselves how the 2 lines interact with each other, or where the 2 lines cross. Well, parallel lines are never going to cross each other. They never interact. So they would have no solution. And we do actually have a third option. I'm kind of running out of space here on my paper, but we'll work it out. So our third option is the lines are the same. Because we are dealing with 2 lines, so if we solve the 2 lines and we graph them and they actually end up being the exact same line, again, that's what that's going to look like, is when you graph the 2 lines, you're only going to see one line, because your other line is actually right on top of it, and so you can't actually see both of them because they're actually the same exact line. So this would be 2 lines are the same. Now, again, the question would be, well, what's your answer here? And if my question is where the 2 lines touch or where the 2 lines cross, notice that they cross at every single point on the line. So this particular one has an infinite number of solutions. And sometimes you'll see people actually write the answer for this one as the line itself. So they may tell you that it's an infinite number of solutions and the line is y equals 2x plus 2. They're just giving you all of the points that actually work, but they're giving it to you in a line format. So these are our 3 possible answers. Again, starting with the first one, we've got the 2 lines crossing. They have a singular point in common, and we call that x comma y. The 2 lines are parallel, meaning they have no points in common, therefore we have no solution. And then our third option, The two lines are the exact same line, and therefore we have an infinite number of solutions. So every single problem that we solve will fall under one of these three categories. Okay, so for our first example, we have 9x plus 9y equals 9 and negative 6x plus 3y equals 3. These are our two equations that we're going to work with, and we want to see how these two equations interact, and we're going to do that for this first type by graphing. Again, when we graph here, we're going to use that slope and y-intercept that we used in that last section that we graphed in the last chapter, and that's where we had that y equals mx plus b. Remember, m is your slope. That's your directions on how to get to the next point, and b is your y-intercept, and remember that is your starting point, or where you want to start using your slope, so that we can get that line on the graph. So in order to be able to use the slope and y-intercept, we need this in that y equals form, and notice that neither one of these equations is in that particular format. So the first thing we need to do before we can actually graph anything is to make those lines in that y equals mx plus b form. So I'm going to just take the first line here, one line at a time, and we're going to solve this guy for y. So the first thing we need to do to solve for y is we need to subtract that 9x. Remember, we always want to move our x away first. Then we're going to get 9y equals negative 9x plus 9. Again, remember, you can't add these together because he's got an x and he does not. And I always like to put my x first, and that's just so that it mimics my equation up here. Makes it really easy for me to pick out the slope and the y-intercept. The next thing I want to do is I want to divide by 9 across the entire problem. Once we do that, remember, we want to reduce it to its lowest format, so y equals negative 1x plus 1. So now that we have everything in the right format, we've got our y equals negative 1x plus 1. Remember that this guy right here is your slope. And just as a reminder, he is always written as a fraction, so he is negative 1 over positive 1, which means we're going to go down 1, and then we're going to go to the right 1. And then this guy over here, he is your y-intercept, and remember, he is always written as a point, 0, 1. For the purposes of graphing, we need to know those pieces of information, and I'm going to show you how to enter in your answer into HAWX as well. HAWX will actually graph it for you, but I want you to be able to understand where everything is coming from as it graphs it. Now we're going to do the exact same thing with our second line. So we're going to take our negative 6x plus 3y equal 3. And we are going to solve that guy for y as well. So we're going to add our 6x to both sides, and that's going to cancel, and we're going to get 3y equals 6x plus 3. Again, making sure we don't actually add those together, and putting our x first. Then we need to get rid of that 3, so we're going to divide everybody by 3. So y equals 2x plus 1. Again, looking at our equation here, we've got our slope, which is our 2, so this is our slope. He's 2 over 1. Again, this is going to be up 2, and then to the right 1. And our y-intercept here is the point 0, 1. So now let's actually put this on the graph. I'm just going to scoot this up. You'll see I've already got a graph here for you. This is one of the things that you'll see in your homework, and I want you to understand how to fill it out. This first box is for your slope. The second box is for your y-intercept. So in this first box, we're going to put negative 1. Notice I don't have to put it in as a fraction. I can just put negative 1. And then for my y-intercept, I'm going to put 1. For my second line, it was slope was 2. The y-intercept was also 1. So that's all we're doing right there, is just putting those values in, slope then y-intercept. Now on your homework, it'll automatically graph it for you. Obviously, I'm going to have to graph these by hand, so let's go ahead and do that. Let's graph our first one. Remember, when we're graphing a line, we start at our y-intercept, which is that 0, 1. So we're going to go up from our origin 1 spot, There's my y-intercept. Remember, my slope was -1 over +1, so I'm going to go down 1 and to the right 1. So down 1 and to the right 1. And remember, you can use slope as many times as you need to get a nice straight line. And I'm a horrible line drawer, so I'm going to cheat a little bit, and I'm going to use this little triangle here and draw my line nice and straight. For this particular section, especially if we're doing this by hand, it's very important that we have nice straight lines and that our lines go across the entire graph, because we don't actually know where these two lines are going to intersect with each other. So we want to make sure that they're nice and straight, we get the right answer. Alright, let's try our second graph. I'm going to use my purple pen here to do this, guys, so we can see the difference. We've got, again, a slope, and our intercept is at 0, 1, so that's going to be up 1 from our y-intercept, and then we're going to use our slope, and we're going to go up 2 and to the right 1. Again, if I want to, I can do that again, making a nice straight line using my triangle here, so I have that nice line all the way across my graph. And if you'll notice, my two lines are intersecting right here at the point 0, 1. So I do have one solution. So I'm going to click one solution, and then here I'm going to put 0 and 1.